Okay, this is standard 6, and I just noticed that I had spelled science wrong, so that's awesome. Um, so standard 6 is our beloved rock cycle. And as you remember, this was super fun. So we started with 3 rock types: igneous, metamorphic, and then the one sedimentary. So then we had to identify the processes that go on to create an igneous rock. So that is understanding that metamorphic rocks can become igneous rocks. They just will be melted, so melting and cooling. If they are melted down in magma, then then cool down, they become igneous rocks. And then sedimentary rock can do the same thing. So I won't repeat the words, but sedimentary rock can be melted and then cooled down to become igneous rocks. Now metamorphic rocks, an igneous rock can become a metamorphic rock if it undergoes heat and pressure. It can turn into a metamorphic rock. And the same is true of sedimentary rock. It can become a metamorphic rock through that same process of heat and pressure. Okay, and then sedimentary rock. Any of these rocks can become sedimentary rock. So igneous can become sedimentary rock, and so can metamorphic. It can become sedimentary rock, and the process for that is weathering, and erosion. And then they just have it, the name of the rock, sedimentation, deposition, and cementation. I don't think you guys can see that down. Can you see that? Yeah. So sedimentation, deposition, and cementation. So these are the processes of the sedimentary rock. And an igneous rock can become sedimentary. A metamorphic rock can become sedimentary. And also a sedimentary rock can be like weathered down and then remade into a sedimentary rock. An igneous rock can also go through its own cycle again. And a metamorphic rock can go through its own cycle again. And then with this rock cycle, we said, well, what are the big players, or what are the forces of energy that make all these things move? Because they are moving. They're heating up, and movement is happening within the atoms and the molecules. And so what are the forces of energy that are actually acting upon this, these atoms, these rocks that don't have life in themselves? So we identified the sun as one of the big players. So we know the sun is primarily responsible for the weathering process, and also water, right? But what's making that water move in cycles is partially the sun. And then we have from underneath the earth, we have tectonic plates. Which we know that there's multiple plates underneath the continents, and they are moving, sliding past each other, colliding and separating. And that action is creating this movement in the rock cycle. Earth's heat energy from the earth. I don't see that. Tectonic plates. Okay, and I'll write this right down here, just so you can see that. Heat energy from the earth. It comes up and it's heating things. We know all about Earth's interior, right? But we learned about Earth's interior after this. But that's the stuff that's heating up the magma in this cycle, and causing it to to melt the rock, and then eventually when it comes far enough outside of the Earth's center, or the Earth's, not the core, but just the underneath the Earth, then it cools when it comes far enough. Sometimes it cools inside of a volcano, and that's called intrusive igneous rock. And then when it cools outside of a volcano, it's called extrusive igneous rock. And we also know that magma is what it's called when magma is inside of a volcano, and then lava is what it's called outside of a volcano.